Welcome student to my channel Educare Maths and Science. Today I also discuss the graphical representation of the linear motion of a body. Linear motion means the body is moving in the straight way. So different before the past video I just discussed the displacement diagram. Here I just discuss here from the graphs you can calculate the displacement and the distance of a body of the moving car or other things. The moving body. So what is the displacement, actual displacement, and what is the actual distance covered? It is just calculate from the graphs also. That is not very tough thing. Just you study the graphs. That is each and every student have got certain knowledge of the graphs. From the graphs you can calculate, and from the graphs you also calculate just slope of this and the acceleration also. Now here is the all these thing is drawing here for the time saving and the better idea and the conception. Just determination of the displacement from the velocity time graph. Here is the graph you drawing here. This is the velocity meter per second. This is the time. Here is 0, 1, 2, 3, 4, 5 second up to 14 second. And here is this is 0. This is a plus 5. That means 5 meter per second. Here is the negative. That is the retardation for that. Now a car or a vehicle is moving in this way. The starting 0 and the starting is 0, u is 0 or the velocity is 0. Now it's starting in this way. You know that means is actually the accelerate. That means the velocity is increase, so accelerate. In that position B, then is decrease the velocity. Is coming here B to C. Here also and total coming. The retardation total minus 5. The velocity is minus 5. Then this is a straight motion. This is the there is no change in velocity, and that is the then the accelerate. Then this there is a change, no change in velocity, and this is ultimately 0. That is a graph here. From there you can calculate the displacement, actual displacement of the body, or the distance of the body and the slope of the graph. So in case of displacement, you know displacement is equal to actually velocity into time. Displacement, not distance. Distance is speed into time. In case of the velocity, displacement, the direction is very important thing because it's a vector quantity. Okay, so velocity into time. Now actually in the graphs you can calculate the displacement by the area covered by this line with the x-axis. That means so area enclosed between the velocity times gauge, this gauge with the x-axis. What is the area enclosed? That means this is the sketch, and this is the x-axis, not the y-axis, x-axis. What is the area enclosed? So if you just calculate the area, measure up the area, you can calculate the distance and displacement both. Okay, now here sketch with the x-axis gives a displacement of the body. You know the first one, what is the different types of area is there? First here, area of ABC, you just, this is a triangle form, area of ABC, and you know number 2 is a trapezium, that is CDEF is a trapezium. Here is also a trapezium of FGHI. So 3 figures, geometrical figure. Now what is the area of this? First you calculate. So you know this is a triangle. So triangle means half base into altitude area. So half, you know the base is here 0 to 5. 0 to 4, this is 4. So this base is 4 and the height is 5. You know this is 5. Height is 5. Very clearly you understand that the concept must be clear from calculation the displacement from the graphs. Okay. Half area of ABC. Very minutely you just see. Area of ABC. Half base into altitude. What is the base? You know this is the 4. And what is the altitude? The height is 5. So half base into altitude is 10 meter. Okay. Now what is the area of this trapezium? You know area of the trapezium is half sum of the parallel side into height. Half sum of the parallel side into height. Half sum of the parallel side. That means sum of the parallel side means this CF and D. What is the, this is 4, this is 9. This is 4, this is 9. What is the measurement? 9 minus 4, 5. And what is this? Just a perpendicular draw. This is 5 and this is 8. The 8 minus 5, 3. Sum of the parallel side you collect. Then this is the height is 5 because this is a 5. Okay. So 5, 8 and 5, 4 into 5, 20 meter. Now what is the area of this? Same thing, sum of the parallel side into height. What is the sum? This is 9, this is 13. So 13 minus 9, this is 4, and this is 12. From this point, you just calculate. From this point, this is 12, and this is 10. So 12 minus 10, 12 minus 10, 2. So 4 to 6, 6 into this 50. So 3 into 5, 50. So this is actually the area. Is okay. Now, in case of displacement, if this is the down, below the axis, x-axis, you just subtract. Up part is at, down part is subtract in case of the displacement. Suppose here, so this is 10, this is the down part, you just subtract. Okay, the 20 is subtract, and this part is up part, so you add. That means 10 minus 20 plus 15. So 15 plus 10, 25, 25 minus 20, this 5. That means actual displacement is 5 meter. Displacement is 5 meter. Okay, but it's okay. So from here to here, the velocity, the displacement of the body is 5 meter, but the distance covered means whole distance. That means total. You just add it. 10 plus 20 plus 15. That means 45 is the distance, but 5 is the displacement. From the graph in which you calculate, that is very important thing is this. Okay, from the graph. This not panic to you. Just clear your conception from the graphs. I just try my best. Okay. Now, is clear to you? Very interesting. Now, from the graph also, you can determine the acceleration, that is the retardation, that is there is no acceleration, no retardation, because the same velocity is not changed. Here is no acceleration, no retardation. That means here is the acceleration is 0. In that case, the acceleration is positive. In that case, is acceleration negative. In that case, the acceleration positive. Positive acceleration means the positive, and is the negative acceleration, that means the retardation. Now, in which you calculate, from the graphs, the line, the slope is very important. So slope actually change in velocity by change in time. Acceleration means actually in case of the mathematics, a v minus u by t. That means change in velocity in change in time. What is in case of AB from here to here? Acceleration velocity change. Original is 0. This is 5. So v minus u, 5 minus 0. And what is the time during time? During time is this. Here is the point. This point. What is this? This is 3. This point. This to this. In that position, 3 seconds. So 3 minus 0. So 5 by 3. This is meter per second square is the acceleration. You just divide. These are 1.66, approx 1.67 meter per second square is the acceleration. From here to here, the body is moving with the velocity this. But what is the acceleration? In case of the graphs, you can find out. Okay. So change in velocity by change in time. So 5 by 3 this. Now from here, actually, this is a retardation actually, total retardation. So in part of BD, actually total retardation. So retardation, there is also the change in velocity. What is the final velocity? Here is minus 5. Change in velocity, v minus u. So minus u is plus 5. Ultimately minus 5, and this is minus. That means minus 10. And what is actually the change in time? Here is 3, but here is you just measure here from the graphs. So D point. So this is 5. So 5 minus 3, 2. So this is minus 10 by 2. That minus 10 by 2, that means minus 5. Minus indicate that is the retardation. Minus indicate that is the retardation. Is okay to you? Clear? No. So here in that case is the retardation. Now, what is the change? There is no change in velocity. There is no change in velocity. Actually, this is the minus 5. This is also minus. So change in velocity minus 5. Change in velocity from here to here minus 5 plus of. Here is change in velocity. Change in velocity. There is no change in velocity. Minus 5. The velocity is minus 5 and also minus 5. There is no change. So if there is no change, the change in velocity is 0. The velocity is not change. Velocity is not change. But the time is there, but velocity is not change. In case of DE, the slope is 0. So acceleration 0. velocity is not changing. What is the velocity in that position? 5 meter per second. This is a negative. Yeah, what is the velocity in that position? Minus 5 meter per second. So there is no change in velocity. Don't be panic. No change in velocity. Just you write d, the slope is 0, so acceleration is 0. Now in that case, the velocity increase. Okay, so there is an acceleration. In EG part, this is EG. So change in this is plus 5. Is okay? Is okay? And from here this is minus or minus 5. Ultimately this is the plus 5 and plus 10. So this, and what is the time taken? Here is 8, here is 10, that means 2. 10 minus 8, 2, that means 5 meter per second square is the acceleration going here. Okay, it's clear to you? In that part the acceleration 0, because there is no change in velocity. Here is 5, here is also 5. Is okay? So this is 0. Now in that case this is hi. In that case this is also retardation because the velocity decrease. What is the change in velocity? This is 0. So 0, and what is this? 5. So 0 minus 5. So this is minus 5. What is the change in time? Change in time, actually this is, in that case this is the 12 and this is 13. So 13 minus 12, this is 1. So what is the retardation here? Minus 5. That means 5 meter per second square is the retardation. So that is the actually the I just see you in which you just study the graphs. From the graphs, you just don't avoid the graphs. Graphs is very important. From the graph you easily calculate. Don't be calculate. Just from the graphs you see this is the acceleration, this is the retardation, this is the same. There is no change in velocity, so there is no acceleration. Okay, just moving in the straight way. S is equal to Vt. In that way, just moving. Okay. So and this is acceleration. This is same. The velocity is not change. That means the rest condition velocity is not change. From here to here, time is passed. Velocity is, that's S is equal to Vt. Distance moving, changing not velocity. Here is the distance is moving, but there is no change in velocity, though there is no acceleration. Here is this. So in this way you study, I just assure you. So in this way you just see my video, you just clear conception about the graphs. Graphs is not panic to you. Okay. So next day I will just upload different videos. Okay. So thank you for that. If you just understand, please share and subscribe the channel. Thank you. Thank you, student. Thank you.